Thank you very much for the introduction, Pablo. Well, after all the special keynote that Elsa has provided, I'm just going to give a small context on the fuel management perspective for wildfire prevention. As you already explained, we have a global change scenario where we have more frequency of extreme wildfire events. And this is also linked with, in many countries that have been developing and investing more resources in fire suppression, and which gives a feedback of the paradox of fire suppression success, which is the more we success in extinguishing and suppressing fires, more fuel accumulation and more dangerous and fire behavior that we can expect. And of course, this implies a higher vulnerability, not only for the ecosystems, but also for the society. And just to keep in mind regarding forest fuels, and we can take a look at wildfires in different temporal and spatial scales, and there are many factors implied that at conditioning the different processes involved, from combustion process to wildfire propagation and ecosystem fire dynamics, which is higher temporal and spatial scale. But if we look at the wildfire propagation, the only key factor that we can manage is fuel. So it's really important and in this context. So just to give some background that Pablo asked us to share with you about our previous research, we have a line of, well, we have been focusing on the research on forest fuel characterization and modeling, and in two main aspects of fuel. The main component of fuel structure, which is linked with the spatial variability of the fuels, and also the fuel moisture, which is a component with a seasonal variability and higher variability. Really, we can only modify fuel structure, but fuel moisture content is also a key component of fuels that we have to know and to model in terms of fire hazard prediction and also fire management, which implies also the allocation of more or less resources, the population alert systems, etc. And of course, the fuel structure is key for fuel management planning and also in wildfire simulation tools that require this kind of information, the spatial information. So, in this line of research, I will briefly explain some of the work done in fuel structure component. And we have been working on new methods and technologies, including airborne LiDAR, terrestrial LiDAR, and other technologies like Forester, which is a patent of the INIA, developed at INIA. And we've been working on new techniques for forest fuel mapping. So not only to provide forest fuel types and regarding surface fuels, but also ground fuels, which are very difficult to quantify in the field and are required in this spatially explicit information. We have been also working on the vertical profile of vegetation, especially looking at the identification of fuel continuity, which is key to predict the transition of surface fires to ground fires, which are more severe and more extreme fire behavior. On the other component of fuels, fuel moisture content, we have been working also on the temporal variability of different species of vegetation, shrub and trees, which gives us knowledge about which are the best indicator species in terms of what could be the fire risk. So this is long-term monitoring that we've been doing in the laboratory for many years, and also in other regional administration are doing and investing resources to provide this information. And then we have also worked on the associated flammability related to this fuel moisture content, which means potential fire behavior differently in regarding this kind of aspect of moisture content. And also, after we have all this information from the field and the species, we have been working to provide tools and methods using remote sensing for moisture content estimation and mapping, which is key because the variability is very high in these fuel components. Another line of research that we've been working on it's on fuel management itself. This is because, obviously, managers that have resources, and not always is the case, but have resources, they have to choose what treatment type, I don't know which one is the best, which recurrence, the location, because we cannot manage all the forest area, so we have to be precise and decide which part of the ground, of the area, of the land are we going to treat. So in this research line, we've been working on the effectiveness and longevity of different types of treatments, looking at the associated flammability and potential fire behavior depending on the time after fuel treatment application. And also on the ecological impacts of these fuel treatments, which are different, of course, and looking at the regeneration and also the biodiversity that can be impacted by these fuel treatments. And all of these, we've been working at different scales in laboratory and also in the field, and also working on simulations provided by different tools that we have. So, in summary of the previous research, is focused just in giving scientific basis to provide knowledge and provide technology so that we can give managers a knowledge basis to adapt and mitigate the impact, the negative impact of these wildfires, so then we can propose sustainable strategies for more sustainable fire regimes, which in fact is the focus of the wildfire prevention, because the wildfires are going to be there always. So we have to learn to live with fires and obtain these fire regimes which are less impacting with a less effect on both ecosystems and also the society. So some key ideas just to finish for this fuel management perspective. How can we provide a more effective fuel management or fuel management for a more effective wildfire prevention? Well, there are some key concepts that we need to know. We have to keep on improving methods for forest fuel characterization and mapping. As we said, we've been working on that. This is something that we have been asked and demanded by the regional governments that need up-to-date high spatial resolution fuel structure regarding surface fuels, ground fuels, because this is a basic input that they have to use when they need to simulate wildfire behavior. So for fuel management planning, this is key. And also reliable spatial and temporal variability of moisture content and associated flammability for a better risk management. And also the fuel management, of course, Elsa has explained it very clearly, needs to be integrated in sustainable forest planning to be effective, because small treatments or small areas treated that are not maintained or are not sustained are not effective. And we have also the option to consider different alternatives. So maybe you cannot apply fire because there are population near and the smoke is not going to be able to be managed by the managers, but we have alternatives to that. So depending on the type of ecosystems and also the combination of different treatments, like mechanical treatment and then maintain with bracing could be good solutions that we can consider and choose. So there is no one recipe, but there are multiple options that we can consider. And of course, the identification of strategic fuel management areas, which are the best areas to be more effective in wildfire behavior, that we can try to reduce the extreme fire behavior, and also to help the fire suppression teams to work more safely and more efficiently. And of course, the long-term treatment and maintenance that I already mentioned. And finally, some of the ideas that Elsa has already talked about, but I just give messages also that I would like to highlight regarding the fuel management perspective, is to give some incentives for fire-smart products in fire-prone areas that could help sustain these management activities for wildfire prevention, like quality recognized animal products for these extensive livestock farmers, for example, or biomass extraction for energy purposes, when it could be a good option. Not always is the case. And well, I'll just give the list of references just in case you're interested. And thank you very much. You want to.